next problem I want to work through is an example of a precipitation reaction. We take two solutions, mix them together, and a solid forms. And this is going to give us another practice problem of how to solve the net ionic equation. So let's say we have barium nitrate. Barium is 2 plus, nitrate is 1 minus, so we need two of them. And we're going to react this with potassium sulfate. From our solubility rules, all nitrates are soluble. Group 1 sulfates are going to be soluble. However, when we mix these two together, we'll make potassium nitrate, which should be soluble. So KNO3. And we would predict this to be soluble in water for two reasons. All nitrates are soluble, almost in every case, and potassium, group 1, is also soluble. However, barium sulfate is non-soluble. So that's going to form precipitate. That's going to form a solid. Well, we have to balance this equation. Again, that's one of those things that's very easy to forget. If you're given an equation, it may not be balanced. One barium, 2 nitrates, 1 nitrate, so that tells me I should have 2 there. Now we have 2 potassiums. We have 2 potassiums here. We have 2 nitrates. We have 1 sulfate. So that should take care of everything as far as balancing it. Now what we want to do is work our way to the net ionic equation and see what are the spectator ions, if any, in this reaction. So first we draw the total equation. So we have 1 barium 2 plus, aqueous, 2 nitrates, also aqueous, plus 2 potassiums, cations, aqueous, 1 sulfate, aqueous, and that's going to yield 2 potassiums, which are aqueous, 2 nitrates, which are aqueous. But barium sulfate is a solid, so it does not ionize. So barium sulfate stays the same. Again, when we write the total ionic equation, everything that is aqueous is ionizing, but the solids do not ionize, so they stay the same. So now what we do is we look for what can we cancel out. I have barium 2 plus here, aqueous, but barium is in the sulfate complex right now, so that will not cancel. So I know for my net ionic equation, we're going to have, and I'll just bring it down right now, we're going to have that barium 2 plus aqueous species. It's going to be making barium sulfate. Oops. Small. All right. Now let's see what else we're going to bring down. Nitrates. 2 nitrates. Nitrate is a spectator ion in this reaction, so we don't bring it down to the net ionic equation. 2 potassiums, also spectator ions, so they cancel. Sulfate, well, we have aqueous sulfate, 2 minus, right? I forgot to put the charge in. Nitrate is -1. Aqueous sulfate, but the sulfate is part of the barium sulfate solid, so that cannot cancel. So we put it in our net ionic equation. So our net ionic equation, barium 2 plus aqueous, a barium ion, reacts with a sulfate 2 minus, also aqueous, to form barium sulfate as a precipitate, as a solid. So this is our net ionic equation. The nitrate and the potassium cations are spectator ions. They're there for charge balance, but they chemically do not change. So being able to dissect a reaction from the complete molecular equation down to the net ionic equation is something I expect you guys to be able to do. And it does take practice of being able to recognize charges, and especially polyatomic species. So you want to make sure you've reviewed all the polyatomic species, nitrate, sulfate, hydroxide, etc.